we're going to take a quick look at the Planet Analytics feeds specifically for building and road change detection. So Planet has built a suite of data feeds for weekly and monthly or quarterly change detection of specific features. And we're powering this with our Planet Scope, which is our near daily 3-meter global revisit imagery. So we lean on the frequency of the imagery to really create a much more robust change detection tools. The more frequently you can image a location, the more confidently you can create analytics that detect true change as opposed to noise between images that can seem like meaningful change, but is actually just due to changes within the scene that are not reflecting what's happening on the ground. So we do building detection and road detection, and then not only do we map out those features at those frequencies, as I mentioned, weekly, monthly, quarterly, we also automatically can detect changes to those features. So we have our standard building and road feature detection. Here's just our website there. You can see the address at the top. We can pull out buildings, landscape, and larger scale. And then same with roads. You can flip through our road detectors. But the really cool thing is the actual change detection. So we have these feeds also for vessel detection and aircraft detection, and those tools work really well. But today we're going to focus on the building and road change detection. We do have a kind of one-pager on all of this. We are the only service that can do this globally at these frequencies and with the confidence that we're able to generate the results in. So this is used a lot in defense and intelligence, just generally in mapping and change monitoring. Civil government is a significant adopter of this capability to help stay up to date on changing infrastructure across the landscape. And what I'm going to do here is just give a quick demo of what our feed looks like. What I will say is this tool you're looking at here, which is our Planet Analytics feeds user interface, is built on top of Planet's APIs. So any type of application similar to this can be created with our APIs. And in addition, our feeds, these actual detections, change detection feeds, can be tapped into with our APIs and plugged into existing GIS software or web-based GIS interfaces. So here I'll just look at a quick demo of a building change detection near the US border, near San Diego and Tijuana. And here we got the map interface on the left-hand side. We're just looking at that monthly snapshot. So there's October 2024. Each one of these time steps on the left-hand side are the detections for that month. So those blue dots showing up, and I'll zoom in on one here, are the actual changes detected. And I'll go back and forth, July, June. So you can go through the time steps like this that look at the monthly. Of course, we have weekly as well. And again, this can run globally at those frequencies. If I turn on the all-time detections here, we're just looking for a one-year period. We're going to look at all the detections. We could do that across that entire span. And then we have the option to look at a heat map of where those detections are mostly concentrated. So if I want to summarize information over a 1-year or a 2-year period, or a 6-month period or quarterly, I can get a heat map generated of those detections and where they're happening most frequently. And then, we're talking about satellite-based detection, so you will get a few false positives here and there. We pride ourselves in our ability to filter by the confidence level. And in fact, I think we do a better job than anything I've seen from satellite in detecting anything larger than a few pixels across. These are 3-meter pixels. What's really helpful here, though, is we can actually very quickly go through each of these detections. So here, we're going to review for the month of July. I'm going to turn off the all-time, make sure we're just looking at the July changes. Review and export. So we filtered by, I think, a minimum of 50% confidence. We're going to open an interactive viewer that looks at each of these. Let's see, there's 69 detections in the month of July 2024. And one by one, we're going to go through each of them zoomed into the specific locations and determine if it's a change that we're interested in saving or downloading as a spatial file. So you can download that as a GeoJSON file that plugs right into your GIS workflows. We'll give it a few minutes here to just load up all those detections, because it's also going to load up all of the imagery and the time series, so that you can pan through and visually cross-reference those detections from the imagery before, during, and after that detection took place. So here's the first one for that month. I can't actually see a lot of detail in this one. This is a lower res look than we usually see. So I'm going to go ahead and say skip that one. I'm actually not interested in that change. Here we've got something that is notable, and these are dynamic scenes. So I can see there is some built environment changes, a few pixels that change from vegetated to non-vegetated, or what looks like an actual structure may have gone in there. So I'm going to save that one. Go to this next one. Again, it does look like something has shown up now. This could just be vegetation senescing. And here we go. Here's an actual structure on the landscape. We can clearly pick out that something has been added onto this one. So I'm going to click on any one of those to save it as an export I'm interested in. Again, here we're actually seeing what looks like a little bit of urbanization taking place in this location. I'm going to save that one. Here we've got a pad, and I can zoom out for context as to where we are and zoom back in. It does look like something under development here. So there is the February on the top left, March, April, May. So we can see the construction happening. And then by what looks like June of 2024, we do have a building, like a roof that's actually gone up and getting closer to that building being completed by July 2024. So again, I'm going to save that one. Now I can quickly go through all of these detections. This one's a pretty clean example of a larger structure being built, but the power here comes in detecting even small, pixel-sized built environment changes. So we do have a quick link here to go and take us to the tasking dashboard, where we can go and send a high resolution satellite right to that location that we found a change of interest, and we can collect a point-based 50 centimeter or higher res image, usually within a few days, to get a closer look if that's of interest. But let's just go ahead and export all the detections or the ones that I've reviewed. So I'm just going to go download the ones that I've reviewed. It'll tell me that I've included 5 of those detections. We left out 2 of those that we deemed not worth saving. So there we go. We've got that downloaded. I'm going to open that location and just show you we can drag and drop it into a GIS tool. So here's that GeoJSON. We'll throw it into our QGIS. And we will zoom to the layers. Now, these aren't the vector outlines of those features. This is actually a bad color to look at, so let's just make it nice and bright. Yeah, so here's the location of that. So it doesn't like outline the building, but it gives you the exact location where that change has happened. I'm gonna throw some imagery in here and see if we can. Yeah, so that was a lot that looks like it got developed. So it gives you all those locations that you detected those changes. In this case, 1, 2, 3, 4, 5 for the month of July. So you could very quickly with that workflow go through quite a few detections and export the ones of interest into a GIS workflow. And again, you could do that through our APIs as well. Just nice to have a user interface.